Hi everyone, I am Jayachandran J, Assistant Professor, Department of Mechanical Engineering, Emmanuel Arasar JJ College of Engineering, Nattala. Now I am teaching about the subject Process Planning and Cost Estimation. Here I am teaching the second unit called Process Planning Activities. So, process planning is the bridge between design and manufacturing. It determines the most efficient and cost-effective way to transform raw materials into a finished product according to the specified engineering blueprints. In manufacturing process, there are 5 important stages or 5 important activities called. First one is planning, second one is design, third one is prototype, fourth one is evaluation, and fifth one is the manufacture. So the process planning activities have several steps or specific activities to plan the specific product to get the required output due to the planning activities. So coming to the introduction to process planning. The process planning is the act of preparing detailed work instructions to produce a part. It acts as the interface between engineering design and the shop floor. So here some questions occur in my mind. What machine to use? Which sequence of operations? What are the cutting conditions? So the major planning activities are here to got the required output to get the specified product as we need. So the first one is interpretation of engineering drawings. The second one is selection of manufacturing processes. Third one is selection of machine tools. The fourth one is determination of machining sequence. The fifth one is selection of jigs and fixtures. The sixth one is quality assurance planning. So the major planning activities have the different steps or specific activities involved in process planning that are to analysis of the finished part requirements as specified in the engineering design. So determining the sequence of operations is required. Selecting the proper equipment to accomplish the required operations. So the correct order of process planning activities are, simply we can say that the first one is analyze, that is analyze the part requirements. Once more, the process planning activities involve different steps. The first step is analyze, that is part requirements. The second one is determine the operation sequence as we need. So the third one is select or selection of equipment, and the fourth one is calculation, that it means calculate the processing times involved in that particular process planning activity. The next one is document, that means the documentation. Every process planning have an important role in the documentation process. It means the complete documentations are involved in the road sheets or other type of documentation as we need. Final one is communicate. Communication is very important in process planning activities. So communicate between the manufacturing to the shop floor. The manufacturing process is very much important due to the process planning activities or process planning methods. And the communication between the manufacturing process and shop floor is very much important in the final stage called communication. So The process parameter calculation are calculated due to the optimizing parameters. So, the optimizing parameters is crucial for tool life and productivity. The three primary variables are cutting speed, that is VC, speed at the tool workpiece interface, and second one is feed rate, small f. The notation we write is small f, that means feed rate, movement of tool per revolution per stroke, movement of tool per revolution or stroke. The third one is depth of cut, that is AP. AP is the suffix, that is the notation called depth of cut AP. Thickness of material removed in one pass. At one pass, the material is removed. That means the thickness of the material is removed at one pass, at one time of interval in the machining process. So, we study about the process parameter calculation. First one is cutting speed VC, second one is feed rate F, third one is depth of cut AP. The formula for cutting speed for the turning and milling operations are VC is equal to pi into D into N divided by 1000 is the important formula for the cutting speed. That is VC is equal to pi into D into N divided by 1000. VC means cutting speed in meter per minute. D is the diameter in millimeter mm. N is the spindle speed in RPM. RPM means unit of speed, RPM, revolutions per minute. The feed rate and MRR, that means MRR means material removal rate, determines productivity. So once again I told, material removal rate determines productivity. That is MRR is equal to VC into F into AP. That is the increasing MRR reduces production time but increases tool wear and power consumption. Once again I told, increasing material removal rate reduces production time but increases tool wear and power consumption. Coming to the next, machining time estimation. Essential for cost estimation and scheduling. Machining time in minute is equal to length of cut in mm, that is L, divided by F, that is feed in mm per revolutions, into N, that means speed. So machining time estimation formula is calculated by T is equal to L divided by F into N, that is machining time is equal to length of cut divided by feed into speed. The next one is selection of jigs and fixtures. So the jig means holds the work and guides the cutting tool. Example, drill or drill bush. So the jig is also called as the hold the workpiece and guide the cutting tool. As we can understand in the drilling process, the specified work material or workpiece is held in the jigs and the cutting tool can be guided due to the particular arrangement called a jig. The fixture means holds and locates the work but does not guide the tool. The jig is guiding the cutting tool, guides the cutting tool. The fixture does not guide the tool, holds and locates the work. And the purpose of jig and fixtures or jigs and fixtures are to eliminate individual marking, ensure repeatability, and reduce setup time. is the main purpose of jigs and fixtures. Also, the selection of machines is the example. Once the appropriate type of manufacturing process has been determined, the next step in process planning is to appropriate machines, equipment, and tools to accomplish the required operations. So there are many factors which influence the selection of machines due to the production rate and unit cost of production, durability and dependability, minimum setup and put away times, functional versatility, that is ability to perform more functions, etc. So the next one is 3-2-1 principle, as we studied earlier in the first unit called Introduction to Process Planning. Also, we can study about the 3-2-1 principle used for precise location in fixture design. The 3 points on the primary base plane means that restricts 5 degrees of freedom. The 2 points represents on the secondary plane, restricts 3 more. So 1 point on the tertiary plane means restricts 1 more. So total 9 DOF restricted. That is, total 9 degrees of freedom are restricted, leaving only loading direction. It means the principle called as 3-2-1 principle. Once I told that 3 points means the primary base plane, 2 points means that the secondary plane, 1 point means the tertiary plane. Here 3 points restricts 5 degrees of freedom, 2 points restricts 3 more. So the 1 point restricts 1 more. So here 9 degrees of freedoms are restricted, leaving only one direction, loading direction. The factors for fixture selection are production volume, complexity, material, and cost. Here, the production volume is the high volume justifies dedicated automated fixtures. It's a simple example. That means the factors of fixture selection. So, high volume justifies the dedicated automated fixtures. And the complexity means intricate shapes need specialized clamping. The material, like fragile parts, need pressure regulated clamps. So the cost is amortizing fixture cost over the total batch size. So these are the factors for fixture selection to get the required output we need. So these are the 3 important or the 4 important factors, including cost also. So we can say that production volume, complexity, material, and cost are the main factors for the fixture selection. The next one is quality assurance methods. QA means quality assurance. QA ensures the process stays within design specifications. Selection depends on the 3 points, like one is tolerance requirements, production rate, cost of inspection versus cost of failure. These are the 3 important quality assurance methods in the process planning activities. Like that, the material selection parameters include the selection of sound economic material is another important aspect of process planning. So the primary parameters affecting the choice of a material are given due to the function, appearance, reliability, service life, environment, compatibility, producibility, cost, etc. So the function may talk about many of the parameters developed for material selection are related to the functions the product must perform in terms of mechanical, physical, electrical and thermal properties of materials. So here the appearance is the aesthetic value of the material must be considered while selecting the material. Appearance is very much important for the process parameters of selecting the material selection due to the parameters included in the quality assurance method. So also the reliability is another important criterion for material selection because of increasing consumer demands for trouble-free products. Also service life is very much important. As I told you earlier, the length of service life over which the material maintains its desirable characteristics is a very important consideration in material selection. Also the environment to which the material is exposed during the product life is a very important consideration. So depending on whether the environment is beneficial or harmful. Here is the environment as we need to the material exposed during the product life into the climate change or environment is the very important consideration. The compatibility is also important in the material selection as well as the quality assurance methods. So this is an important factor influencing material selection, especially whenever more than one type of material is used in a product or assembly. So the producibility is the final one before the cost as we need. So producibility is the ease of producibility of an item is an important parameter in the selection of material. So cost of the material is a significant factor contributing to the overall cost. The next one is statistical process control. Here the SPC, that is statistical process control. Control charts monitoring X bar and R charts for stability. The process capability called CP. The notation is denoted by CP, C suffix P. Measuring if the process can naturally meet tolerances. Allows for proactive adjustment before defects occur. So the inspection technologies are CMM. That means coordinate measuring machine, high accuracy for 3D geometries. So the coordinate measuring machine is the inspection technology for the high accuracy of 3D geometries. The vision systems like high-speed inspection for surface defects. The next one is go or no-go gauges, that is fast, low-cost manual checking for mass production. Is the another type of inspection technologies we study. So 3 types of main important inspection technologies are CMM, coordinate measuring machine. The second one is vision systems. The third one is go or no-go gauges. The next one is non-destructive testing, also known as NDT. Non-destructive testing used for critical safety parts like aerospace, medical, automobile, etc. So ultrasonic testing, internal flaws, dye penetrant, surface cracks, X-ray radiography. These are the different types of non-destructive testing used in the process planning activities or methods. Set of documents. As I told earlier, documentation is very important in process planning activities. Like that, it is a very important role in the process planning activities to analyze, to determine, to select, to calculate. These are documented as a process plan in the root sheet to document as a process of activities included in the process planning activities. So The process planning results in a standard set of documents to communicate instructions to the shop floor. It's the final step called the communication. The communication instruction to the shop floor for the selling of products. That means manufacturing the particular product or any product. A process planning is very much essential. The process planning activities are the sequence of operations required for the determination and selecting the proper equipment to accomplish the required operations. That is the process planning activities. So the final step is communication. Here it means that the set of documents, a standard set of documents to communicate instructions to the shop floor is the final step of process planning activities. The next one is the route sheet. The master document of for a part. It lists, as I told earlier, route sheet is the main process of documentation to get the required operations or provides the information like part identification, numbers and names. So description of the processing steps in each operation, operation sequence and machines, and standard setup and cycle times, also tooling requirements for each operation, production control information showing planning lead time at each operation. So the reasons for process documentation is very much important. As we told earlier, process planning is essentially documented for the following three reasons. The master document, which means for a part it lists operation sequence numbers, description of operation, machine tool IDs, estimated setup and cycle times. So the three reasons, there are three reasons essentially documentation is needed. So the first one is to have a record on how a part is processed in order to plan future parts with the similar design requirements in a consistent manner. So the similar design requirements in a consistent manner is to be calculated by means of the processing order. The second one is to provide a record for future job quoting, cost estimating and standard costing systems. The final one is to act as a vehicle for communication. So here are the three main important reasons for the process documentation. Also, communication is very much important, as I told earlier. So the final step in process planning is to communicate the manufacturing knowledge to the shop floor through the operations sheet and the process drawing. It is very much important. The final step in process planning is to communicate the manufacturing knowledge to the shop floor through the operations sheet, that is route sheet. Operations sheet also known as route sheet. Also the operation sheet is also called as instruction sheet or traveler or planner. There are different names for the operation sheet called route sheet, instruction sheet, traveler, planner. The route sheet lists the production operations and associated machine tools for each component and sub-assembly of the product. So here this communication is essential to ensure that the part will be processed according to the most economically possible way determined through process planning. So also the process documentation and corresponding communication provide a basis for improved part consistency and quality in manufacturing. So the approaches involved in process planning are mainly process planning, and the second one is computer aided process planning, that is CAPP, retrieval CAPP system, generative CAPP system. That are the two important approaches to process planning. The operation sheets, as I told earlier, the operation sheets are the detailed instructions for one specific operation. That sketches of the setup, tooling required, clamping points, specific machine settings. These are the main important specifications that are involved in the operation sheets. So operation sheet also involves the complete data related to the product or manufacturing the product detail. Example, component number, drawing, name of the component, material, quantity to be completed on, and routing the section, machine, operation number, operation description, tools required, fixtures and other accessories, time to set up operation, and total time required, etc. are also involved in the operation sheets to provide a record for future job coding, cost estimating and standard costing systems to act as a vehicle for communication. It's the main important term in the process planning activities called operation sheets. So the final step in process planning is the communication is essential to ensure that the part will be processed according to the most economically possible way to determine through the process planning activities. Also, the process documentation and corresponding communication provide a basis for improved part consistency and quality in manufacture. So, bill of materials, that is BOM, list all raw materials, components and sub-assemblies and essential for inventory management and procurement. Next one is tooling and gauge list. Specifies every cutting tool, insert, holder and inspection gauge needed. Ensures all hardware is prepared before the job reaches the machine. These are the main important tooling and gauge list. The next one is economics of process planning. A technically perfect plan is useless if it is not economically viable. Planning must minimize the total cost per part. So economics of process planning is very much important in the process planning activities. So the selection of process planning system involves the evaluation and selection of the best process planning system for a particular firm, involves numerous engineering management decisions. So the process involves identifying, weighing and comparing various interrelated factors. The major factors to be considered while selecting the best process planning system are the general environment in which process planning is conducted, the organizational structure of the company, and the technical expertise available to the company, and the needs and objectives of the company regarding the generation of manufacturing information and process plans. So, three commonly used tools for acquiring and documenting knowledge are flow charts, decision tables and expert system shells. These are the three commonly used tools for acquiring and documenting the knowledge of flowchart, decision tables and expert system shells. The next one is cost components. There are three main cost components. They are fixed cost, variable cost, overhead cost. Fixed cost means tooling, fixtures and programming. Variable cost means labor, raw material and energy. Third one is overhead. Overhead means factory rent, administration and maintenance. These are the three important cost components. Once again I told fixed cost, variable cost and overhead cost. These are the three important cost components in the process planning activities. The next one is break-even analysis. The break-even analysis is the deciding between processes. Example, manual versus CNC. CNC means computer numeric control. In manual, low fixed cost, high variable cost are needed. In CNC, high fixed cost, low variable cost are needed. So, even break-even point says the quantity where both costs are equal. This means the break-even analysis. So, at the break-even point says that the quantity where both costs are equal, which means the break-even analysis occur in the different processes. That the decision of processes between manual versus CNC. Coming to next one, minimum cost versus maximum production. The minimum cost speed decides the slower speed save on tool replacement. Once again I repeat, minimum cost speed, slower speed save on tool replacement. Maximum production speed is the higher speeds reduce labor cost per part but burn tools faster. The process planners find the optimal balance. So the planners must ensure the minimum cost versus maximum production rate according to the minimum cost speed, maximum production speed. So here the two approaches the planner has to be taken. They are manual process planning, computer aided process planning. In computer aided process planning, it is divided into two types, that is retrieval CAPP, retrieval computer aided process planning system, and generative CAPP. The concepts, advantages and limitations of both manual and computer aided process planning are also discussed in this chapter as I mentioned earlier. So the CAPP systems I also told about the variant and generative. So the computer aided process planning includes two different CAPP systems like variant and generative. The variant means modifying existing plans for similar parts. Also, a plan or a specified means of activities has been planned due to the different ideas. So that idea can be existing or modifying on the similar parts. So it means the variant, that is modifying existing plans for similar parts. And the generative is the creating new plans using logic and AI. So the main name also mentioned, and also we can say that generative means creating new plans according to the logic and AI means of activities or ideology. We can say that the two CAPP systems included in the process planning. That is, first one is variant and second one is generative. Coming to the next, lead time and lean planning. So the lead time is the reducing non-value added time, that is waiting or moving, is the main purpose of lead time. Reducing non-value added time, which means the lead time. Optimizing batch sizes is the lean planning. So the batch sizes are optimized due to the various planning activities according to the optimization of the product knowledge in accordance with the expert system shells of knowledge engineer, knowledge base, interference engine, report generator, and answers. That means the expert system structure. So we can say that the different means of developing manufacturing logic and knowledge to support a process planning system, the acquisition and documentation of manufacturing knowledge is very essential. It is generally agreed that knowledge structure should be determined prior to any type of program coding or data presentation. So, single minute exchange of die, that is SMED, principles in planning, or the production engineers need a tool to develop a knowledge structure format that can be used in an interactive process and will emphasize what questions to ask and what data to collect to support a standardized format. Also, there is a need for systems tools that can acquire and document knowledge in such a manner as to bring together, analyze and display the resulting manufacturing knowledge in a consistent and well-structured format. The three commonly used tools acquiring and documenting knowledge are, as I told you earlier, flowchart, decision tables, and expert system shells. These are the three main commonly used tools for acquiring and documenting knowledge. First one is flowchart, second one is decision tables, third one is expert system shells. The flowchart is the one of the most commonly used tools for the collection and display of manufacturing knowledge. Format of flowchart is very much important for every process planning activities. Flowcharts are widely used because they are commonly taught in computer programming subjects. Also, the flowchart includes disadvantages like the flowchart focus on process rather than on the structure of decision logic. Flowcharts provide no check against incompleteness, contradiction, and the redundancy. Flowcharts often employ abbreviations and hence they are defective for effective communication of knowledge. So, the decision table are a system or logic tool to bring together, analyze and display complex decision logic in such a way that means it can be readily grasped. So the format of a decision table is very much important to acquire the benefits of decision tables, to ensure accuracy, eliminate redundancy, and avoid contradiction. Decision tables provide knowledge, structure, and readable documentation as a byproduct. So, coming to the conclusion, process planning is the core of manufacturing efficiency. The integration of parameters, tooling, QA means quality assurance, and economics is essential. So a continuous improvement is the goal to improve process planning activities. So here the complete section is briefly, as I told, in the second unit called process planning activities. So the process planning activities are the analysis of finished product or finished part requirements as specified in the engineering design. as I told earlier. So the process planning activities determine the sequence of operations required and the selecting the proper equipment to accomplish the required operations. So in manufacturing process, the process planning activities are very much essential for every part as we manufactured due to the different types of activities performed on the basis of the manufacturing product or manufacturing material. So once again I told, process planning activities involve these types of steps. First one is analyze, second one is determine, third one is selection, fourth one is calculation, fifth one is documentation, and the final one is communication. Communication means the manufacturing unit in between the shop floor or the selling agencies. So the analysis or analyze means the part requirements. The first step in process planning activities is analyze. Analyze means part requirements. Second one is determination. Determination means operation sequence. The third one, selection, means selection of equipment as we need to machining the particular product as we need to get the required shape and size of the material. So selection is very much important. So the required means of equipment can be selected on the basis of the material we selected, on the material characteristics and the performance of cutting or machining the material. So the next step is calculation. Calculation means processing times. As we studied earlier, different formulas, cutting speed, speed rate, and tool life, tool wear, etc. has been calculated due to the calculation by using the formulas or other means of appearance in the tool design or machining the process of process planning activities. The next one is document. That means the documentation. Documentation is the process plan. As we told earlier, root sheet is the example for documentation. Documentation is very much important for the process planning activities. Here the process planning activities are the main selection parameters, which involves the machine selection, generally requires determining how the part would be processed on each of the alternative machines so that the best machine can be selected. Also, at the machine selection phase, the firm has to be decide whether to make or manufacture or buy. That means manufacture or buy. Buy means purchase the component part. In this regard, break-even analysis is the most convenient method, as we earlier studied. That is, break-even analysis is the most convenient method for selecting the optimum method of manufacture or machine amongst the competing ones. So the calculation processing times means the appropriate set of machines required is selected. The next step is in the process planning is to calculate specific operation setup and times in the cycle times on each machine. Finally, with the calculated cycle time, appropriate machine rates, that is the cost of machine ownership or using rupees per unit of time, are applied to calculate the expected standard cost for the given operation. So the documentation is very much important, as I told earlier. So communication, the final one is communication. Continuous improvement is the goal. So Communication is the best example for the continuous improvement of the required goal. So it is the final step in process planning is to communicate the manufacturing knowledge to the shop floor, that is through the operations sheet and process drawing. Also, the process documentation and corresponding communication provide a basis for improved part consistency, that the improved part consistency and quality in manufacturing. So communication is essential to ensure that the part will be determined through process planning. So communication process knowledge is very much crucial or very important in the process planning activities. Hence the final step is very much important, that is communication. Communication between the operations sheet and process drawing through the manufacturing knowledge to the shop floor. Communication in between the manufacturing knowledge to the shop floor management or shop floor. So these are the three main points included in this conclusion of this chapter or unit. Thank you all.